Good day guys. Today I will be showing you how to solve for the um, equilibrium forces system. So we are now in this the next topic of engineering mechanics. So in this force system we are about to solve for two forces in a system. So by the way, I cannot solve as I promised last meeting this problem because this is just example of how we of how is this or how to construct a free body diagram. So this is just a simple topic, so I hope you you are now used to make an FBD of a problem. So I will be solving this for problem because this is just a easy problem. So this is the problems that we are going to solve for today. So I already draw the problems, so we can now begin. So first, for this problem 308, the cable and boom shown in figure P-308 support a load of 600 pounds. Determine the tensile force T and the cable and the compressive force C in the boom. So this is the cable, as you can see, and this is the boom. So the tensile and the compressive force in that system. So first we would like to make or do a FBD of this system. So first, this is the 600 pounds. Then the boom, the compressive force is this. So I will put here, this is the 45 degrees, the compressive. Then the tensile, so 30 degrees maybe here. So this is the tensile force with 30 degrees. So now, because we are now in equilibrium force system, so our force now should be force X and force Y should be equal to 0. So you will be seeing this this equation a lot in this equilibrium force system. So for us to solve these two, we would like to solve for the summation of force X and equate it to 0. So as we know, going to the left is negative, so T cosine of 30, then positive plus C cosine of 45. Then we will equate it to 0, and then the summation of forces Y, so both are positive, so T sine of 30 plus C sine of 45 minus 600 equals to 0. So in this we got two equations. So using our scientific calculator, so we just have to input these values. So here it is. If you have a scientific calculator, so we have two unknowns, T and C, so we will choose this one with two unknowns. So here we will just input the cosine 30, so it is negative, so we will put negative cosine 30, then positive cosine 45 equals, then 0, because this last column here, or this part here, is the constant. So this equation of the forces x doesn't have constant, so it will remain 0. Then input sine 30, then also sine 45 positive, then because it is minus 600, and we will always the constant will be transposed in the other side, so here it will be just positive 600. Then we got the answer for T and C. So T is 439.23 pounds, and just click the equal button again, so you will have the answer for C, 95 pounds. So here, what will you see first? For example, in this solution, we got the T first and the second C. So the order of in your equation is also the order of your solved values. So if we put first the T, then cosine, and we should also put again the T first, then the cosine, so it will give us the value of T and for the C. So you should always put it in order. So summation forces x, T cosine plus cosine of 45, then summation of forces y is T sine 30 plus sine 45. So it should always be in their proper places. So this is now the answer. So if we compare it with the book, so there it is, 439 and 538. So 439 and 537, or it is equivalent to 538. So our answers are correct. Then now we will solve another one, which this problem 309. So also I already draw the problem. So we are asked to, so does the problem state that a cylinder weighing 400 pounds is held against a smooth inclined by means of the weightless rod AB. So then determine the force P and N exerted on the cylinder by the rod. So this rod exerts force P and the incline respectively. So this incline also has the force N, or the normal force. So we will put here the weight of 400 pounds. It is given on the book. So now for the FBD, of this system. I will just make a cross here that represent this center of this cylinder. So we have 400 pounds here, the weight of the cylinder. Then the force P, so by the rod, so with 25 degrees, it is here, force P, so 25 degrees. Then the N is always perpendicular to the plane, so here this will be the N. So if this is 55 degrees, then this remaining angle is 35 degrees. So our N is 35 degrees. And 35 degrees. So as you notice, if we look at these two, it is just in same FBD. You will just need to imagine it. If you have a good imagination, so you can just play with this the force system. It is just an easy topic, by the way, because we just have to solve for two unknowns here, two equations, two unknowns. So again, the same as this problem in the top, we can summation of force x, so negative n cosine of forces x equals to 0, cosine of 35 plus p cosine of 25, then equals to 0. Summation of forces phi equals to 0. So if you put n first, so in the next equation we should also put the n first. So n sine of 35 plus p sine of 25, then we have a constant there of 400 equals to 0. So in our calculator, what we will be solving first is n, then p. So in our calculator, we will just input this equation. So n negative cosine of 35, then positive cos 25, then the constant is 0. So next is n sine of 35, then p sine of 25, then positive 400. So because this 400 will be transposed on the other side, so it will be positive 400. So that's it. We have 418.61 pounds. So click or press the equal button, so you will be directed to this answer of P, which is 378.35 pounds. So this is our answer. If we compare it with the book, so the book has 378 and 418. So P is 378 and N is 418. So we got the same answer. So next, we have this problem here. So problem 310 state that a 300 pounds box is held at rest on a smooth plane by a force P inclined at an angle theta. With the plane as shown in figure 310, if theta is 45 degrees, determine the value of P and the normal pressure N exerted by the plane. So just like here, there is a normal force here on the plane. So now we have normal force here N. So in this kind of problem where theta is just equal to 45 degrees, it is given by the book. So if we find the angle here of 30 and this N is perpendicular to the plane, so this will be 60 degrees. Then so in this problem we would like to rotate axis. So I would like to make this my y prime, and this plane would be my x prime. So because this P here is 45 degrees to the plane, so for us easier solving, so we would like to rotate the plane, the axis. So, and as you can see, if this is 30 degrees here, right, this plane to this, then this weight is, if this is 30, then this is perpendicular to there, so this would be just 60 degrees. So the weight is 60 degrees to the x prime. So now we can make the FBD. If you will, there. So if you look it like this, so the W is here on the left side or on the third quadrant. So it is 60 degrees down left, 60 degrees here, 60 degrees. This is the 300 weight. Then the normal force is, can put it here. Then the P is here, 45 degree. So, or you can put it down. So this is the P with 45 degrees. Then that's it. That is the missing, the two forces that we need to solve. So again, we can just solve it without any problem. So summation of forces X is P cosine of 45, then minus weight of the 300 cosine of 60 equals to 0. We should always equate that to 0 because we are now on equilibrium force system. Then summation of forces Y equals to 0. So P, then sine of 45, then we should put the N first, plus N, then minus, this is minus also, so 300 sine of 60 equals to 0. So we can now input it in our calculator. So we will first solve for P, then for N. So first is cosine of 45, positive. Then because we don't have N here, we will put that 0. Then next is positive 300 cosine of 60. Then here negative sine of 45. 45. Yes. Then we have n here, so we would like to put 1 there, then positive 300 sine 60. So we got 212.13 pounds and 409.81 pounds. So we got these values. So in the book we have, so the book has 212 pounds and the n of 410 pounds. So 212 and 409.81. So it is just equal or equivalent. So 212. Yes, we still got the correct answer. So if you notice, the pattern is just the same. You will just need to find the angle for each forces and find the best way possible to solve the problem. So in here, as you can see, it is we already got the angle for all. So the difference is this problem has 4 forces than the previous 3 problems. So but still it is just easy. So summation of forces x. So you will not need anymore to make FBD, because as you can see, this is already an FBD of a system. So summation of forces x, we have first we would like to put the unknowns. So negative p cosine of 30 plus f cosine of 60, then minus 300 plus 200 cosine of 45 equals to 0. So summation of forces y equals to 0, then p. So remember, you should put what you put in the first equation. So if I put p in the first, then second is f. So now I should also put the p first, then the f. So p sine 30 plus f sine 60, then so 300 is a x going to the x, so it is not included in our y forces. So minus 200 sine of 45 equals to 0. So as you can see, this topic here is easy. So negative cosine 30, then positive cosine 60, then transpose these two because these two are constant. So if you transpose these two, the 300 is positive, so 300 positive, then the 200 will be negative. So minus 200 cosine of 45. Then we have negative sine 30, then positive sine 60, then transpose, so we will have 200 sine of 45. So we have p and f. So our p is negative 133.24 pounds, and for f, just click or press this equal button, so you will be directed next to our f. So f is 86 0.37 pounds. So this is the answer. So in the book we have here, so the book also has negative 133.6 and 86.1. So it is similar answers. So that is how you solve for the equilibrium force system. So for next, there's many more problems here in the book, so we can try to solve for our next video. Maybe it looks challenging just looking by this system. There's many connections here. Then we also have these two problem here. So we have then this one. So already dealing with pulleys, right? So that's it. Next video tutorial, I would like to solve this and this, and also this one. So if you like to be notified, so please do subscribe and hit the button bell, so you will receive notification when I uploaded the tutorial. So that's all. So for reference, I will show you my solution. So this is my solution. So if you notice error and mistake in my solution, so please don't hesitate to comment down below and mention my mistake, so I will be more cautious next time. So thank you for watching, and please do subscribe. Thank you.